There we go. All righty. So as we're all settling in, we will get started in just a second or two. All right, well, let's go ahead and dive in. So good morning, afternoon, evening, everyone, and welcome to the CentOS Automotive SIG monthly meeting. This is the monthly call that we record, that we get together and talk about the technical status of the project and find out all the different stuff that's going on. I have a very brief agenda, which is out of date because this is the agenda from last month. Really, all that we have today is I'm just going to put technical status. So wrote it all on a different page. So there were a few things that happened this month that I should probably just turn it over to Pierre to go over. And Pierre, let me know if you want me to click on any links.
Sure. So just the Jifro nicely put at the top the reminder to where things live. So you can find the code on gitlab.com/CentOS/automotive. You have a number of repositories there you can browse. Everything that is under source will have the sources. Everything under RPMs will have the sources to build the RPM, so spec file patches. You'll have the sample images. You'll also have the doc repo. The documentation, which you can see live at sigs.centos.org/automotive. It contains a number of informations about what the SIG produces, how you build Raspberry Pi images, how you customize, how you can customize your images, how you can contribute to the SIG from an RPM point of view. Where do you contribute RPMs depending on where you want things to go. So that's the page that Jeffrey just showed there. If we go back to the slide. So there are a few things we've looked at recently, and I'm going to take them in reverse order from what Jeffro put in there. We looked at using USB gadgets, configuring a Raspberry Pi to be USB gadget. So USB gadgets is something in the Linux kernels that allows a device plugged via USB cable to appear to the laptop that it is connected to as if it was a network device. So the idea is that you have a Raspberry Pi image, you flash it onto an SD card, you plug that SD card into your Raspberry Pi, you power the Raspberry Pi via USB-C cable to your laptop, and the Raspberry Pi boots, and there is a network created between the laptop and your Raspberry Pi, and you can SSH into the Raspberry Pi while it is not plugged in anything other than the USB-C cable to your laptop. So it's not connected to the network. So imagine if you're in a very restrained network environment from your company, or you just don't trust the Raspberry Pi to be plugged to your network at your house. Maybe you just don't have the network there. So that's an easy way where you could SSH into the Raspberry Pi over the USB cable and get it to work nice and easy. So this is something we have worked on. We have made it working on Linux. We have made it working on Windows, and both of these are in the documentation that Jifro linked to earlier. There are a few pages that we've been pointed are not available in the documentation, but if you go to the building page, at the very bottom, you have a number of extra resources, things like the deluxe encryption. So yeah, building images, and then you scroll to the bottom there. All the way to the bottom. There you have additional resources, so like how do you use OS3, how do you update an OS3, how do you create your own, how you can customize your own OS build, images, your templates, how you can embed containers into the image, how you can encrypt that image, and we'll get to that. And then you have here as well how to use the Raspberry Pi as a USB gadget. We're not quite there yet, but we have everything in place, but we don't have the final piece missing here to actually make these images available, so that you can directly grab an image from autosd.sigs.centos.org and download that image, flash it onto the SD card, and get it as a USB gadget there. It's almost ready. We just need to figure out to find a mechanism to build these images and make them available. So it's soon to come, but not there yet. So that was the first point. Just go back to the slide. The second one is I'm going to skip the Linux firmware. I'll come back to it afterwards. I'm just going to mention the Lux, encrypting images with Lux, because I've mentioned it just a few seconds ago. It's part of the same, at the bottom of the building images documentation. You have an whole page about how you can encrypt your system using Lux directly for the image you're building with as build. Coming back to the Linux firmware is a pretty big package, RPM package. It's about 200 meg of firmware binary blobs for all sorts of boards, which is of high interest for a generic purpose operating system such as RHEL or Fedora or CentOS Stream. But in our case, we are targeting a much smaller set of devices, so we don't actually need to have all the firmwares that are contained in the Linux firmware. So as a proof of concept, we reduced the size of the Linux firmware, and we created a Linux firmware Automotive RPM that is in the Automotive SIG repository. And currently, it basically only contains the Raspberry Pi firmware and maybe a few others, or dependent one. But and the idea is, just to reduce the size of the image, as well as the need of, we don't need to have all of the firmwares if we only care about a few parts. And the last point is the first one on the list here, is that with the chip shortage and the increase in cost of simple device such as a Raspberry Pi, just to give you an idea, in France, the price of a Raspberry Pi has about doubled in a year. We went from about 100 to 150 euros to between 200 and 300 euros for board with a case and SD card provided, fan for the CPU and other kind of things. That is a lot, but it is also bringing an interesting conversation, because that makes second-hand Android devices a lot closer in price to the Raspberry Pi. I bought an S9 from Samsung, a Samsung Galaxy S9 from 2020, so it's 2 years old phone. It has 128 of gig of memory, of disk, sorry, 128 gig of disk, and the Raspberry Pi, you can have 128 gig of disk. You can even have more than that in micro SD cards, but the micro SD cards we also know are pretty fragile. So you have better storage or more reliable storage. The phone has 8 gig of memory. Raspberry Pi has only 4 gigs, and the CPU in the phone is a lot better than the CPU on the Raspberry Pi. And the difference between cost between the Raspberry Pi and the phone was 70 euros. So it starts to be a lot more interesting to actually look at the Android devices, over Raspberry Pi. And there are places I know in the US where the Raspberry Pi are just not available anymore. So that's what brought us to look at the Android devices as a mechanism to have access to an AR64 system. So I have used the work that Eric Curtin, who is in the call, has done, and he opened the path to this investigation, and we looked at what it would take to build. So Eric made it easy for anyone to have p-root, which is the unprivileged equivalent of a ch root. So ch root, you can have a Linux ch root in an Android device if you root the phone. You'll have a Linux p-root if you do not root the phone. And the recommended way is not to root your phone, because if you do root it, Android will reset itself from scratch because something or someone has tampered with the phone. So I'm going to erase all the data on the phone. But also a number of applications are going to refuse to work because something has tampered with the phone. So we've been looking at p-root over chroot. And so Eric has made it easy to get a Fedora environment in using p-root, using Termux on the Android devices. it is interesting. It is an interesting angle to look at. We are able to compile software. We were able to compile things like the time package. We just took the time sources and we are able to do configure and make install without problem. We have run into two issues. One of them is we are not able to build RPMs directly, and this is weird. Basically, when you do RPM, I took the source RPM from Koji. I downloaded them into the phone. I do RPM build dash rebuild, and it builds and it fails at the very last step, which is writing on disk the actual RPM binary file. I got things like the debug source file. I also looked at the XPack package, which is one I was using as a test package in another project. And this one has a sub package that is a static RPM, static sub package, and that sub package was written fine on disk. But the XPack RPM, the time RPM, the main binary files are not written on disk with a weird CPI or errors about the file not being found. So we are not quite sure what's going on here. Our inch is that there is something in the Android kernel that prevents it. Maybe it's something in the S9 Android that I have, or the S9 device that I have. Maybe it's something specific to Android. We're not quite sure there. And it's a little bit one of these cases where we want to go to the bottom of it because we're curious about it. But on the other side, if it, what are our chances? If we find the issues, if we can fix the issue, what are our chances that we can contribute that fix to Android, that we can get that fix deployed on phones, including older phones who are now 2 years old? It's fairly low. So we may investigate it. I may root my phone, my device, just to see if we can get to the bottom of it. But at the end of the day, it's probably not worth spending too much time on that because we can't get that part working. And the second issue is, well, using these devices to build images would be pretty neat. Unfortunately, when we build images using OS Build, at one point we are building the file system when we need to mount that file system, and that mount command needs admin access on the device, and PRoot does not have full admin access, and so the PRoot actually does not implement the mount system call. So we are not able to build RPMs, and we're not able to build images on the Android device. But if you need a place where you have an AR64 system and all you do is configure and make, that may actually be a viable solution if you're looking for AR64 hardware. So that was the first point, the 4 points in there. We have also looked at being able to have image manifest hosted outside of the sample image repo. So you can point when you do your make command, you can actually say, well, my manifest, my folders with the manifest image are somewhere else. That's handy for if you want to customize things on your side. Sample image, some of the sample image are already available in autosd.sig.centos.org, but not all of them, and especially the gadget one is not there yet. Also, like the Neptune one, I believe is not there yet. So we also don't have a nice image with a with a nice graphical interface that people can download. That's work in progress, so it's there. And the idea is to have this image being generated by the CI pipeline. So it's part of the CI pipeline, which includes the test pipeline. So that's about it. And I think I've covered everything else in this slide in my previous chat. That was a long rant. So if you have any questions or if you want anything I've said wrong, please.
No, I don't think so. Does anybody have any questions or any comments on all of that? Very quiet.
No, it all looks great. I think we certainly have left no stone unturned in looking at ways that people who don't necessarily have access to server class hardware can still do some meaningful development on ARM. So I think it's really cool.
for sure. Okay. Well, that was really the majority of what we've had for the meeting this morning. Kind of to open discussion now. If anybody has any burning issues that they would like to bring up, please just go ahead and unmute and let us know.
There is one last thing that we are looking for the Android devices, but we have very little hope. Is could we by any chance run an actual virtual image on an Android device, which may solve some of the permission issue that we're having with the pivot. We have low hopes on that. Things like dev KVM are not available on the devices. Even running the QEMU ARCC4 on the proot gives you a permission denied error. So I'm just starting to look into that, but I don't have high hopes. But yeah, for completeness, I'll mention that we have or are looking into that as well.
One question for the Samsung: are you you're just using the Samsung Android that came on the phone, right? It's not you're not loading a separate Android on there.
No.
I'm wondering if there might be something within the Samsung firmware that is blocking you.
So Eric has also access to other hardware. It goes a little bit to the question I was having earlier. I don't know if it's worth spending too much time on that.
Right.
But depending on how we may try to push it a little further, but I don't know that we'll push it much further.
Yeah, it's something I looked at ages ago. I caught COVID and I got bored, and I think Ian McLeod mentioned it at the time, and I said I'd try. It works great as a build machine if you want to build like C, C++, Rust, Golang binaries, but obviously you're a little restricted. It's very similar to what Podman or Docker containers do. So if you want to do anything, if you want any sort of lower level runtime access, it's not great, but it works great as a build server or a build machine.
Yeah, I think the only other that, as you are encountering these issues, Pierre and Eric, I'm struck by, if we look at what Yocto does in order to be able to do all of the things it does for image building as an unprivileged user, they're all related to the same stumbles that we're seeing when trying to use proot, essentially. So.
Yeah,
so for example, we'd like Yocto generates image files without ever having the ability to do loopback mounts. Doesn't have root, so it doesn't do loopback mounts. And if you peel back the onion on that, you discover that it does that by spoofing the ownership of files on the file system, and then taking advantage of the fact that makefs commands can be run in non-privileged mode if they're targeted at a file, and they can be pointed at a directory to populate the file system. So that's an interesting one. Image Builder takes advantage of the kernel, uses the kernel's knowledge of the file system to populate the file system. Yocto uses user space tools that can accomplish the same thing. So, but again, at that point, I mean, the other interesting thing about image building is if you've got something you can flash an image onto, why aren't you using that to do your development? So perhaps because you only have one of them, and you can't build the image and then flash it, etc. So that's interesting stuff.
There is a question in the chat about using ARM-based notebooks. So today's there are 3 categories of laptops that I know of that are easily ARM-based. One of them are the Chromebooks from Google. They are the latest Apple M1, and they are the Surface tablet. So there is a team in Red Hat that has looked at the Chromebook. That has looked at the Chromebook with some success. Eric is saying. Eric has placed an order from Chromebook 3 months ago and is still waiting on the list. I have placed an order for M1 and I got 3 months ago, and I got the tracking number for the order earlier today. So there is progress on my hand. So there is hope on the horizon for you, Eric, hopefully. And I know Ian has a surface that I don't know if he has played with it or not, but we have looked a little bit at this hardware for this exact reason.
Hey.
Shout out, Ian.
Yeah. No, it works. It has Hyper-V. I mean, I feel in both cases, we're kind of dishonoring the primary use case for these things, just using them as virtual machine hosts, but they do work, so they're available. There's also a ThinkPad that does Windows for ARM that's supposed to be coming out. It was supposed to come out last month. It's apparently been delayed, but that's very closely related to some of the hardware we're looking at. The ThinkPad X13S is another Windows for ARM. Is
it a Chromebook or what's it running?
No, it's a straight up ThinkPad. It's part of the ThinkPad line, so it's being marketed as it's X, which I think is generally the slimmer travel ones, but yeah, otherwise it's being sold very much as a general purpose Windows machine, just with an ARM processor.
Huh.
So.
There's actually one Chromebook, I can't remember which one, but it's pretty much just a stripped down version of a Q Drive 3 board. I think it's expensive though.
So I think this problem is getting better, basically. That's what I'm saying. We're well placed if we really do round the bend on this chip shortage and Raspberry Pis go back to being under $100 for the 8 gig version. I think we've got it made.
Yeah, I have a sneaking suspicion this chip shortage is going to go on for at least another year, though. That's what the analysts are saying.
Sounds like someone with inside information.
Yeah, not exactly. Just world weary, I guess.
Yes.
There are also a number of other boards that are out, so that they're basically have already been manufactured, were manufactured prior to the chip shortage. The ones that I'm thinking of are some of the ones from 99 boards, the Beagle board in particular, like there's a small pocket Beagle that has been made in large quantity, and it uses a TI chip, but it is an ARM processor. It actually has a built-in DSP. I don't know if something like that would be worth targeting because they're not ubiquitous. But
I mean, one thing is even Raspberry Pis that were manufactured before the chip shortage, the secondary market for a lot of these things has gone up because they're so much harder to find. The other challenge I think we face is that hard as it is to believe, like less than 4 gigs is a fairly constrained environment for the type of RPMs and whatnot that we build. I think a lot of it comes down to that's roughly the size of our own builders for things in Fedora, and in RHEL. So the Beagle boards that I'm aware of, I think many of those have less than a gigabyte of memory. Some of them are 512 megs, and some of them are a gig. Whereas the Pi and these things like the Surface and the M1 have a reasonable amount of memory.
Right.
That's the main concern.
I thought the Pocket Beagle had. Oh, you're right. It only has it actually has 512 megs of DDR3. So it's a very underpowered chip.
A very forgetful machine.
A very forgetful
very
machine.
Too little memory.
I'd say a lot of swapping going on.
Yeah, which is not.
It's funny that was state of the art a few years ago. Lenovo Duet. I'm not familiar with that one. I can actually get one here in Canada for $300. Now it makes me want to go get one. So in general, sorry, go ahead.
So I think they're releasing their new line of the Duets. So they're their tablet.
Adam, you're extremely faint.
Yeah, we
I'll
can't
type
quite
in
hear
the
you.
chat.
There we go.
Here's the X. Oh, the X. Oh, that's X12. You said the X13 ARM processor.
X13S is the one I'm actually looking.
X13S, right? Because I'm looking at this regular X13 apparently has
S must stand for Snapdragon.
X86. Okay.
%90 recycled magnesium in the case as well. So
That's cool.
I think that may be one of their things where almost all magnesium has some amount of recycled content, just
Yeah.
like steel. So yeah.
Magnesium is one of those. I believe it's one of those things that's very easy to recycle. So
Anyway, I will flag it high and high and wide when I see if these become orderable. I'm really looking forward to it.
okay.
We'll see.
Yeah, and Adam says they're releasing the new line of Duet tablets so that the originals are going on sale. If they are available, maybe we should buy a crate of them just to have them available as build servers. It's funny how every single conversation always kind of devolves down to talking about hardware.
We are geeks. We love our toys.
Pretty much. Oh, I don't have it. I took it to I took it to my office. I have a remote server. It's actually a Minnow board. It's an x86 4x4-inch board with a I don't remember what processor is on it, but I 3D printed a case for it. I was very proud of myself. Finally getting hands on with things for the first time in a while. Okay, well, we can probably give people a half an hour back. I don't see any, unless we have stuff to talk about. There's no, one of the best practices for meetings is to not sit there in silence and just, if we're out of stuff to talk about, we can move on. We will be having the office hours again in a couple of weeks. So, and of course, everybody's always available through the normal normal means, through the mailing list and the chat channel. So unless anybody's got anything else, we can just wrap it up.
Thanks, all. Be well.
All right. Thanks, everybody. Appreciate it. Great conversation. I'm going to look up these Duet tablets, Adam. Thank you. And we'll see you all in a couple weeks. Have a good day.
See you all.
Thank you. Bye-bye.